Okay, let's look at homework 14, problem number 1. Right? So by integration, we want to find the area of the disk, which is described by this inequality in polar coordinates. All right, so let's find out what kind of disk this is. All right, so I'm going to turn this into equation so that we know the equation for the circle. All right, so let's say R is going to be equal to, right, 2a sine of theta, right? Remember that conversion equations for polar coordinates would be x equals r cosine of theta and y equals r sine of theta. Right? So since we would like to have r sine of theta instead of just sine of theta, I'm going to multiply both sides by r. So it's going to be r squared here, and r is going to be there. Right? Then you notice that when you do x squared plus y squared, it's going to give you, so r cosine theta, so square that. So it's going to be r squared cosine squared of theta plus r squared sine squared of theta, right? This is equal to r squared, then quantity, factor out the r squared, you have cosine squared of theta plus sine squared of theta, right? Which is equal to 1, right? This is a famous trig identity. So this is equal to 1, right? So therefore, x squared plus y squared is exactly the same thing as r squared, right? So we can conveniently rewrite this equation as, right, r squared is going to be just x squared plus y squared, right? This is equal to, right, so you have a 2a, right, r sine theta is same thing as y, right? So this is an equation in rectangular coordinates, right? Then we can probably rewrite it so that we can find the center of the circle and also the radius, right? First, I'm going to move this guy over to the other side by subtracting 2ay, right? So you will get x squared plus y squared minus 2ay, right, is equal to 0, right? Then you notice that if we had the plus a squared here, we can actually complete the square. So I'm going to add a squared to both sides, right? So I'm just adding a squared to both sides, right? Then we can rewrite it this way, right? So x squared is x squared, right? By combining these three guys to complete the square, you have quantity y minus a squared, right? And this is equal to 0 plus a squared would be a squared, right? So this is going to be a circle with radius a. Radius shows up here, centered at x equals 0 and y equals a. So it's going to look like this, right? Let's sketch the picture. Right, so here's the x-axis, right, and here's the y-axis, right. Then I'm gonna just label, here is the y-axis, this is our x-axis, and this is the origin, right. Center is 0 comma a, so I'm gonna put the center right here at a, right. And let's sketch, draw a circle centered here and with radius a. So it's going to look something like that, Alright, so this is a circle, and where r is less than or equal to a sine of theta is basically the disk inside. So we can just shade that. So this is the disk. Whoops, sorry. Right, this is the disk we're talking about. Right, so this is the disk. Right, so let's try to set up a double integral for the area of that disk. Right, so the area A is going to be a double integral because it's a two-dimensional object, so you have two integral here. Right, remember the area element for the polar coordinate is r dr d theta. Right, so remember that that's just the area element, so this guy is simply dA. Alright, then we just have to have bounds for here, so here's going to be a r. Alright, r here, and theta, and theta here, right, to describe the entire disk. Right, so first, since we're doing the integral with respect to r first, we're gonna fix the theta. Right, so by fixing theta, so we have fixed theta, so we could have like a picture like this. So starting from here with the fixed theta value, so this is going to be a theta value here, so this is theta. Right, then r value, r is just the distance from the origin, so it's going to be r value is from 0 because start from the origin, and up to the circle. Right, remember that the circle has an equation r equals 2a sine of theta. Right, so r value is going to start from 0, so 0 goes here, so that means you're right here, and all the way up to the circle, which is going to be 2a sine of theta. All right, then so that will cover this line segment. So in order to cover the entire disk, you're gonna have to start from, so angle is gonna start from 0, so which is here, and then gradually increase the theta value, so from 0, right, so starting from 0, right, then you gradually increase the theta value. Oops, sorry. Right, we want red, so gradually increase the theta value like here, and here is pi over 2, and increase even more and more. Right, and to cover the entire disk, theta has to go up to positive, so something like that, to pi. So theta goes from 0 all the way to pi, so this is going to be pi right here. Right, pi. Right, so this is the double integral that represents the area of this disk. Right, so all you have to do is evaluate this double integral, and you will see that the answer should come out, because we already know the area of the disk, right? Because this is a disk with radius a, so it's a pi radius squared, so answer should be pi a squared. Right, but you need to evaluate this double integral to see if you can get the same answer. Right, that's it. I hope that this will get you going.